So this video is going to be a recap of what we did during the training about computer-aided drug design under bioinformatics. As I said during the training, there are so many things we can do with bioinformatics, but because our there are so many angles to it, depending on what you are interested in. But for this workshop, we looked at the computer-aided drug design using some biological information online and some applications to see how we can, start designing a drug or start developing a compound to be a drug. We also have an aspect chemoinformatics. So in computer-aided drug design, we deal with bioinformatics and chemoinformatics. Chemoinformatics has to do with chemicals and informations online, using our systems to harness chemical informations online and then see how we can use them or utilize them in the process of drug development. So as I said, this is not the only thing we can do with with the bioinformatics or chemoinformatics. There's so many things you can do with bioinformatics. Uh, but for the sake of computer-aided drug design, we're going to need bioinformatics and chemoinformatics. These are general definitions of what bioinformatics is, which you can take a look at it. So we said involves using computer to acquire, manage, and analyze biological information. It incorporates elements of molecular biology, computational biology, database computing, internet. So these are things that are brought together to form bioinformatics. The other angle of it, as I said, is chemoinformatics. When you do with chemical data. So bioinformatics is for everybody. So I told you it's for everyone. You can see everyone has a role to play in it. So don't be surprised when you see people from other fields of science also talking about using bioinformatics or computational tools in their work. So for the sake of our training, what can we do with bio and chemoinformatics data online? We can do drug repurposing. Drug repurposing is trying to find another indication for a drug already that has already a drug already known for a particular indication. Trying to see whether there are other indications that same drug can be used for. For example, I use paracetamol. If you have a paracetamol, you take it for headache, fever. So I can decide to study paracetamol to see whether it can be used to take care of diabetes or to manage diabetes, hypertension, hyperlipidemia. So if I'm doing this with paracetamol, I'm trying to do what is called drug repurposing to find another indication for a particular drug with an already known indication, already established indication. We have natural product drug development. Apart from repurposing, we can decide to study new compounds from plants. Not only from plants, we can decide to study synthetic, we can decide to do synthesis of new compounds and also study them for their drug likeness. So it's either if you do from nature or we do synthesis. We can also do drug likeness prediction with with uh, CADD tool, computer-aided drug design tool. We can get a compound and predict whether they are drug-like based on certain rules or certain parameters. We also have ADME. You can do ADME prediction. You can do drug design. We can do molecular docking simulation. You can do dynamics. You can also do sequence alignment. As I said, there are so many things you can do using computer aid. Uh, it's not only drug design. There are so many other things we can do. You can see sequence alignment. Most of applications for all these, they are online applications. Some of them are the ones you can also download your line in your system. Uh, so, and there are more you can do. But for a start with this would be good for all of us. At least if we start little, you can now go into the details. So many other things you can do with bioinformatics. But the thing is that if you start throwing so many things on someone who is new to bioinformatics, it might be sounding so abstract. But you have to take it gradually, gradually, gradually for a better understanding. So the opportunities in bioinformatics and chemoinformatics, as I told you, recently we have this call for paper presentation for proposal. So and the call is still on. What interests me most is the third option here. Next slide, you see the options available. That options available, and then see the third option there: computer aided drug discovery, use of computational approaches. You see in the bracket chemoinformatic or bioinformatic to discover new molecules with predicted anti-malaria activity or new anti-malaria drug targets. So, and they stay on up to August 26th. So there are so many opportunities in bioinformatics. There are so many workshops going on online now, which if you don't have a background detail, a background information, you know, it might be so much, it might look so abstract to you. But if you have, this basic training, this basic information, uh, to help you to key in easily or to understand easily whatever else you hear about bioinformatics or chemoinformatics, computer and computer aided drug design as well. So I want to talk about some rules on which we do certain predictions when we want to analyze compounds or drug likeness. As we discussed, we have Lipinski's rule. Lipinski's rule that you can see what Lipinski did. They selected, and his colleague, they selected uh, 2,245 compounds from World Drug Index database and define drug-like characters through this set. So they actually they look for something in common in these compounds. And they lay this as a guideline to be able to if you have a new compound you are studying for drug likeness, so they use these parameters, they match them with the already existing compound that are drug, and then see what the most of these compounds have in common and laid it as a guide for new compound development. And Lipinski's rule was based on bioavailability of compounds, oral bioavailability of compounds. So you can see the rules he set: no hydrogen bond, number of hydrogen bond, sorry, not more than 5. Hydrogen bond donor not more than 5. Hydrogen bond acceptor not more than 10. Molecular weight not more than 500. And C-log, octanol water coefficient not more than 5. It is called Lipinski's rule of 5. It's not 5 in number. It's only 4. It's 4. So why it's called Lipinski's rule of 5 is because the conditions are in multiples of 5. You can see 5, 10, 500, 5. So it's called Lipinski's rule of 5. So we have another rule, MDR-like rules. The researchers on this classify their own based on drug-like or non-drug-like. So either a compound is drug-like, non-drug-like. You can see number of rings not more than 3. Okay, sorry, number of rings more than 3. Number equals above 3 for drug-like. For non-drug-like, you can see less than 2, equals or less than 2. So these parameters and other parameters, like Weber rule, a Gauge filter, or BBR rules, blood-brain barrier rules, comprehensive medicinal chemistry database rules. You can read more about these rules, but you can see the parameters set. These figures, these parameters here are set to help you, to guide you in studying compound for drug likeness. So when we talk about, when we start using our computational tools, there are some certain terminologies or certain abbreviations we'll be seeing. Something like SDF is a structured data format. It's a format we are going to meet as we download compounds or we download